Hello, welcome to an ACI and Red Hat virtualization demo. We will be showing how to leverage EPG segmentation and policy and how to automate a full stack with Ansible. We will be working with a three-tier application that has a web component, a bare metal database, and a front-end. The front-end and web components will be running on the Red Hat virtualization cluster. We will be mapping EPGs at app level logical networks. So we'll have a logical network for web, a logical network for front-end, and we will be using contracts to filter between them regardless of the subnet. We will have a single subnet for front-end and web application. We will automate the complete stack, including virtual machines and network and security, using Ansible. First, the Ansible playbook will provision virtual machines to a Red Hat virtualization cluster. We will be working with a bridge domain that will contain a DHCP label to forward to a DHCP server that will provide addressing for all virtual machines on the same subnet. The bridge domain will also implement distributed routing on the ACI fabric. We will have an L3 out that provides connectivity for external users to reach that subnet. We will also use Ansible then to provision logical networks and EPGs for a front-end, and then the Ansible playbook will configure the virtual machines to perform the front-end role by installing a reverse proxy on them. We will then create another EPG for web, and we will provision the web application, a very simple PHP application, on those virtual machines. We will configure the front-end to use high availability by pairing the HA proxy VMs with Keep Alive. So we will configure a virtual IP address of 12.12.1.11.10 as the active virtual machine. Now we will have virtual machines that are on different logical networks and therefore have to communicate through the fabric between them. They're on the same subnet though, so unless we put some security, they will be able to communicate with one another. So we will provision contracts as well as part of the Ansible playbook to implement distributed security. Our contracts will limit the external connectivity exclusively to the front end. Any traffic from external users trying to reach directly the web virtual machines will be dropped. Similarly, only the front end will have access to our web application, and only the database will only be accessed from our web tier. Any attempt to reach the database from the front end will also be dropped. Of course, we also have a contract that enables our Ansible server to provision at all moments all virtual machines and elements in the system. Finally, because the ACI policy is implemented on the leaves in a distributed way, even if the virtual machines move, they will remain connected to the same logical network. So let's look at the demo. We start by looking at the Acme Open Apps profile. In this application profile, currently we have no EPGs configured on the APIC. Let's review the Red Hat Virtualization Manager, where we see that there are no virtual machines running. And if we look at the cluster, we see that we have two hosts, Red Hat Virtualization Host 1 and Host 2. No VMs are currently running, nothing is provisioned, and we see that no network is configured for the Acme Open Apps application profile. We're going to kick off our Ansible playbook. This playbook will be working first on the APIC to create the necessary networking, and then on the Red Hat Virtualization Manager to clone the virtual machines from a pre-existing template. This part of the video has been accelerated. You can see that first we're creating a bunch of contracts, and now we're creating the EPGs, front-end and web servers EPG. We're associating the EPGs to the Red Hat virtualization domain, and we start cloning virtual machines now that we have networks to connect them on. We can now look at this information on the Red Hat Virtualization Manager. If we just click on refresh here, we will see that the networks has been created. We see now the logical networks for the front end and for the web server, and we see the script is now configuring the front end virtual machines, cloning them. We see the full application profile that was created by our Ansible playbook with the web server front end, the contracts that enable connectivity for our application, and we have associated to pre-existing contracts for MySQL. So MySQL provides access to an existing database, as well as to the Ansible servers. The front-end virtual machines have been cloned. And if we look at the Red Virtualization Manager VMM domain, we can see now the front-end VM is running on one of the hosts, and the frontend 2 is running on the other host. So the APIC inventory has been learned, and the Fabric administrator can clearly see that the VM has been correctly connected to the front-end EPG of the Acme Open Apps application profile. If we click on the EPG operational tab, we can see the virtual machines connected, and we can see front-end 1, front-end 2 virtual machine, again correlating physical and virtual. You can see the IP address and MAC address matching those obtained by the DHCP server for those virtual machines. The playbook continues running, and Web 1, Web 2, and Web 3 are currently being cloned from the same template. Now we can see the playbook has finished running and all the infrastructure has been created. We have all the networks, we have all the EPGs, contracts, and we have all the virtual machines correctly connected to the right EPGs. As the information is refreshed, we can see that all virtual machines are announcing now through the agent to the Ref Manager what's the IP address. And if we click on the web servers, we can see again Web 1, Web 2, Web 3. They're all running on the second host, Ref host 2 at this point in time. We can look at the VMM domain again, and if we refresh the information, we can see on the Ref host 2 the virtual machines that have been allocated at frontend 2, Web 1, Web 2, Web 3 are on that particular hypervisor. We can look for each of them where they are connected. Again, they're connected on the right EPG. We can see that the contracts have also been provisioned, and here we can see the various contracts enabling access to our proxy for provisioning the applications through our repos. Now we're going to run a second playbook that is going to provision the application itself. It's going to install PHP, Apache on the web tier, and it's going to install HA proxy and keep alive and configure it for high availability on the front-end web servers. So again, all these VMs are connected on the same subnet. They get IP addresses from the DHCP server, and now we're installing the application on it. We will see that we can see in the backend that the hostname has been configured, and the agent is now announcing that the web tier has been correctly installed. And soon enough, we'll see the same for the keep alive HA proxy pair. Once the playbook has finished the configuration, our application is ready to work. And soon enough, we see now that we have two IP addresses reported for the front end, because the active server is reporting also the VIP configure, which will be the one where we're exposing our application, which is 12.12.1.1.10. And we see that the Fabric has also learned that IP address now corresponding to front end 01. Let's review again our application. So we have external access through the MyOpen contract that enables us to reach our application frontend, then an HTTP app and a MySQL contract that enable the rest of the communication between the tiers, as per the design that we mentioned at the beginning of the session, of the demo. So here we're connecting to the HA proxy statistics page, and we can see that the backend servers are correctly available. And if we click here, we can see our application is a very simple PHP application that is going to say that it can connect to the database and print the host name of the server that we're hitting. So we can see the load balancer is working and we're hitting the 3 servers. We can see that's matching our virtual machines. And the statistics updated on the HA proxy. We can see the database is running on bare metal. So we have a MySQL contract that enables access to a bare metal database that is running on the DB network EPG. So we can see that we can seamlessly access the database that is bare metal, and the contracts apply both to virtual machines on Ref and to bare metal environments. We can look at the contracts also between the front end and the web tier. These virtual machines are communicating, being in the same subnet, and they're communicating thanks to the contract between them. So HTTP app is a contract that enables the web front end the web servers and the front-end servers to communicate with one another. And that's how the application works. We're hitting the load balancer hits the servers, which go to the database. So if we remove that contract, http-app, the application will break, because now we can hit the front end, but the front end cannot reach the backend servers. So if we click on it, we can see that eventually times out. There's no contract now between, if we refresh, we can see that that contract is gone, and in absence of the contract, we are on a whitelist model at this moment. Now let's add back that contract. So the application is up again. And now we're going to look at vMotion. So we're going to migrate a VM. All these web VMs are now running on a single server on the Red Hat Virtualization host 2. So we're going to migrate them, one of them, the web 1, to the rep host 1. And we'll see that connectivity resumes. This is thanks to live migration on Red Hat Virtualization, and also to the fact that the fabric constantly provides the right communication inclusive of the contracts that are provisioned on the relevant leaves. So we can see here there are all moments. We can hit all of these servers. Again, we can hit, the migration is going and completing. We can see that we can hit all of the servers at all moments. Now the migration has happened. The VM agent will eventually communicate the IP address to the new hypervisor. And if we look at the web server operational tab, client endpoints, we can see that now the web 1 is reflected as running on Red Hat Virtualization host 1, and everything continues working as expected. Thank you for watching.